Hello, we are in Chapter 4, Section 4.9, Synthetic Division. In this video, we're going to go over problem number 6, in which first we're going to divide a polynomial by a monomial. The divisor is x plus 2, and we want to know the number behind the minus, so we present it as x minus negative 2, and that will be the number associated with the divisor in the synthetic division diagram. We then observe that our dividend is of degree 4, but there is a missing term 2 degree. So I'm indicating my degrees to know where to put the missing 0. Negative x to the 4th really means negative 1 times x to the 4th. So negative 1 is the leading coefficient. Then we go minus 3 by x cubed. The missing term is the square term, so that's why we need 0. Then plus 5x to the power of 1, so 5 is the coefficient by the first power, and then the constant term is negative 7. We bring the leading coefficient down, multiply by the number associated with the divisor, add the numbers in the column, and keep going. And at the end, negative 2 plus negative 7 is negative 9, and that's the remainder of our division. Now we identify the quotient. Just remember that the quotient will be 1 degree less than the dividend, so degree 3. So negative 1 x to the 3rd will be the leading term of that quotient, and then go minus x squared plus 2x and plus 1. And to finish the result of the division, we add the rational expression with the remainder on top and the divisor on the bottom. And that is the full result of our division. And now in part B, we will treat our dividend as a function, as a polynomial function, and we will find p of negative 2 to compare with the remainder found in part A, using the remainder theorem that tells us that we should be getting the same number. So in evaluation, we just plug the number in for every instant of the variable x. So to evaluate p of negative 2, we go as follows. Since we're evaluating a negative number, I'm going to keep it in parentheses to make sure that we use the order of operations properly. So we have minus negative 2 to the 4th, then minus 3 times the negative 2 to the power of 3, plus 5 times the negative 2, and then minus 7. Starting with 4th power of negative 2, that's 16, so we have minus 16. Then minus 3 times the 3rd power of negative 2, which is negative 8. Then 5 times negative 2 is minus 10, and minus 7. So we have negative 16, and then negative 3 times negative 8 is plus 24, and minus 10 minus 7 is minus 17. Now negative 16 plus 24 is 8, 8 minus 17 is negative 9, and that will be our final answer. And we compare it with the remainder of negative 9 we obtained in part A, that the remainder theorem should give us the same number.